Good morning, my name is Arvindra Nalaki Kalsavam from class DAD 5B. My McTree number is 01DAD21F1073. Our topic was about hydraulic valve lifter. There are several types of valve lifter available, each with its own design and operation. The main types of valve lifter commonly used in internal combustion engine are: firstly is hydraulic lifter. Hydraulic lifter, also known as hydraulic tappet, utilize oil pressure compensate for valve drain clearance. The second one is roller lifter. Roller lifter are similar in design to hydraulic or solid lifter but feature a roller wheel at the bottom of the plunger. The roller reduces friction between the lifter and the camshaft, resulting in smoother operation and reduced wear. The third one is solid lifter. Solid lifter, as the name suggests, have a solid construction without any hydraulic mechanism. They are require manual adjustment to maintain the proper valve clearance. The last one is mushroom lifter. Mushroom lifter, also known as a flat face lifter, have a mushroom shaped top surface instead of a round plunger. They are commonly used in older engine design and can be either hydraulic or solid. Now I will talk about hydraulic lifter. The hydraulic valve lifter diagram is an essential component in the engine valve system. It plays a crucial role in ensuring the smooth operation of the engine and optimizing its performance. Understanding how the hydraulic valve lifter works can help mechanics and car enthusiasts diagnose and fix any issues that may arise. A hydraulic valve lifter, also known as a hydraulic lifter or tappet, is a small cylinder-shaped device located between the camshaft and the valve. It is responsible for maintaining proper valve clearance and ensuring that the valve opens and closes at the right time during the engine operation. The hydraulic valve lifter diagram consists of several key parts, including the lifter body, plunger, check valve, and spring. The lifter body houses the plunger, which is a small piston-like component that move up and down based on the camshaft rotation. The check valve allows oil to enter and exit the lifter, while the spring provides the necessary force to maintain contact between the camshaft and the valve. When the engine is running, the camshaft rotates and pushes against the plunger in the hydraulic valve lifter. This causes the plunger to move upward and compress the spring. As the spring compresses, oil is forced out of the lifter through the check valve and into engine oil gallery. This creates a hydraulic cushion that effectively adjusts the valve clearance and ensures proper valve operation.
Selamat pagi Tuan Adi Firdaus. Nama saya Christopher, anak lelaki Vincent. Nombor metrik saya 01DAD 21F1048. Saya nak berbentang tentang hydraulic valve filter. A hydraulic valve filter, also known as a hydraulic tappet, is a crucial component of a four-stroke internal combustion engine. It helps maintain power, valve clearance, and enable the engine to operate smoothly and efficiently. And then the hydraulic valve lifter works by using a small piston and a hydraulic fluid chamber to take up any gaps in valve clearance. It is typically located between the camshaft and the engine valve. When the camshaft rotates, it pushes against the hydraulic valve lifter, compressing the hydraulic fluid and causing the lifter to expand. This expansion ensures that there is no excess clearance between the camshaft and the valve, preventing valve noise and engine performance issues. Uh, Down there, I have shown the hydraulic taper components. Then, why are valve lifter important? Valve lifter help to control the combustion process by letting fuel in and exhaust out. When valve lifter were out, your valve can't open or close properly. This reduces the amount of power the engine can produce. When one of your valve lifter goes bad, one of the two scenarios can happen. That is, if the lifter is connected to an exhaust valve, the valve can't get rid of the fuel air mixture. And the second one is if the lifter is connected to an intake valve, the fuel or air mixture can't get into the combustion chamber. Either way, it throws off the engine's valve timing and the engine won't run as well as it should. A function of hydraulic valve lifter. The first one is valve clearance adjustment. The main function of hydraulic valve lifter is to automatically adjust the clearance of gap between the engine's camshaft and the valve train components, such as the pushrod or rocker arm. The adjustment compensates for any wear or thermal expansion in the engine components and ensures that the valve closes properly. The second one is noise reduction. Hydraulic valve lifter contribute to a quieter engine operation compared to engines with solid lifter. The hydraulic design minimizes the impact of valve train noise, resulting in a smoother and quieter engine performance. The third one is improved performance and longevity. By maintaining proper valve clearance automatically, hydraulic lifter contribute to consistent and optimal engine performance. The reduction in wear and tear on valve train components can contribute to the longevity of the engine. Consistent valve timing is the fourth one. The proper valve clearance is essential for accurate valve timing in the engine, and then the hydraulic lifter helps maintaining consistent valve timing, which is critical for combustion efficiency and power delivery.
My name is Muhammad Mahdi bin Muhammad Isa, and I'm going to tell you about construction of hydraulic valve lifter. There are a few parts, which is body, plunger, push and seat, plunger spring, plunger retainer, check ball and ball retainer. The body is a cam follower which houses all other parts of the lifter. The interior surface of the body and the exterior surface of the plunger are ground to very close limits, then each plunger is selectively fitted a body to assure free movement with the least possible clearance. The push rod seat is free to move with the plunger in the body, and as its name implies, it provides a spherical seat to support the lower end of the push rod. The plunger spring pushes the plunger and seat upward against the push rod with a 10-pound load, which is enough to take up all lash clearance between parts in the valve linkage without affecting positive seating of the valve. A hole drill in the push rod seat permits oil to enter plunger, and a feed hole in the plunger permits oil to flow down into the chamber below the plunger, the lower chamber, to compensate for thermal expansion and constriction of valve. A hydraulic valve lifter consists of a cylindrical body that houses a piston spring and a small reservoir of oil. The lifter is positioned between the engine's camshaft and the push rod or rocker arm, depending on the engine's design. Next is the operation of hydraulic valve lifter. When the engine is running, oil is supplied to the lifter through the engine's lubrication system. The oil enters the lifter and fills the reservoir. As the camshaft lobe comes in contact with the lifter, it tries to compress the lifter. The oil in the lifter acts as a hydraulic fluid, allowing the lifter's piston to move upward against the force of the spring. This upward movement compensates for any clearance or latch in the valve train, ensuring that the valve closes properly.